first example of where we're going to have a transformation or multiple transformations from its parent function. So our parent function is the absolute value of x. If you remember from the parent functions, the shape of this graph is going to be a V. All right, now our new function is g of x, and that's in red, and it has a -2 and a +5. We want to figure out what happens to our graph from its parent function to the new function. What are the transformations? So let's talk about this first thing here. This is a -2. What we say is this is inside the function, and it's going to affect the x-axis. So let's go backwards here a minute. We've already talked about this slide already. When it is a minus, it's inside the function, it's a minus, it's going to shift our entire graph to the right h units. So in this case, we're going to shift to the right 2 units. So now let's describe it in a verbal. We're going to have a horizontal translation right 2 units. And what that does is it affects the x-axis. So in our rule, I have my original ordered pair. I'm going to have to add 2 to every x value. All right, there's our first transformation. Now I'm just going to change colors and identify this +5. And what happens with this +5? This +5 is what I say outside the function, and it's a plus. So I'm going to go back to my purple slide. When there's a plus outside, what happens is it shifts our entire graph up k units. So in this case, it is 5 units. So it's going to go on the y values, shifting the y values all up 5 units. So let's describe this second piece. We're going to have a vertical means up and down, vertical translation up 5 units. Now for the rule, you're going to add 5 to every y value. We're adding 5, we're shifting up 5 units. Now we're going to move on to graphing the parent function. So we're going to graph this function first, the absolute value of x. So our function is y equals the absolute value of x, or f of x equals absolute value of x. And we're going to stick with the same 5 x values for every assignment problem, every test question will be these 5 numbers, -2, -1, 0, 1, and 2. And we're going to evaluate the function. So we're going to substitute in -2 in for x. So the absolute value of -2 is 2. And we continue to do the same thing by substituting into here. Absolute value of -1 is 1. Absolute value of 0 is 0. Absolute value of 1 is 1. Absolute value of 2 is 2. Now what I've done is I found the 5 ordered pairs that will come up with our parent function graph. So let's go ahead and graph these. So I have 0, -1, -2, 1, and 2. Then 1 and 2. Now let's go ahead and graph them. -2, 2, -1, 1, 0, 0, 1, 1, 2, 2. Here is our parent function graphed out in the blue. I'm going to identify that as my parent function, f of x, equals the absolute value of x. Now what I want to do is I want to find the graph for the g of x function, applying the rule. So I want to graph this red function right here. So I'm going to separate out what are the things I need to do to change it from the blue function to the red. So let's talk about +2. I have to do +2 to every x value. So I'm going to add 2 here. So it's going to be x plus 2. Then on my y, I'm going to add 5. So all of these numbers here, we're going to add 5. All right. And that's going to come up with our new function. So our new function will be y, or g of x. Maybe I should just stick with g of x using that same notation. G of x equals the absolute value of x minus 2 plus 5. All right, so we're ready to go. So we're going to start with the x. We're going to add 2 to it. So negative 2 plus 2 equals 0. Now we'll go to negative 1. Negative 1 plus 2 equals 1. And we'll start with the next one. 0 plus 2 equals 2. And you probably can do these in your head. Just since I'm teaching this to you for the first time, I'm writing it down for you. 1 plus 2 is 3. And then for the last one, 2 plus 2 is 4. So I found all of the x values, the ordered pairs, for our new function. Now let's go to the purple. We're going to add 5 to every y value. So we're going to have 2 plus 5 equals 7. Go to 1. 1 plus 5 equals 6. Go to 0. 0 plus 5 is 5. Now we're going to 1. 1 plus 5 equals 6. And then 2 plus 5 equals 7. And we're going to get our new 5 ordered pairs. Here are our ordered pairs. 0, 7, 1, 6, 2, 5, 3, 6, and 4, 7, which make up of our red g of x function. We're going to go over 0, up 7, over 1, up 6, over 2, up 5, over 3, up 6, over 4, up 7. Here is our new function in the red that identifies the g of x function with the 2 transformations. Notice it's moved 2 to the right and 5 up from the original blue parent function. Now let's identify the domain. Remember, the domain are all your x values. There are no restrictions on its domain. So it's negative infinity to positive infinity. Every x value is true. For the range, where does it start on the y? It starts right here at 5. So we say then, y is greater than or equal to 5. And that's how you graph your first example of a transformation set.